Hello students, today we are in lecture number 8 of chapter 1 Electrostatics. This is B.S Pandey. Student, today we are in another very important topic. It is named electric field. Electric field. First of all, students will try to understand what is the meaning of this field. Actually, the field is nothing but the area or space. Okay, area or space surrounded. If we talk about the electric field, we try to understand which is the source that making the electricity, the static electricity. Actually, we are talking here, and then we'll understand the field of that electricity. Actually, students, we have been studying in standard 11 about the gravitational field. In similar way, we'll define this electric field. Suppose, students, I have been placed a positive charge over here. This is positive charge, and I have been placed over here. Now, I want to find out the space or the field, that is the area over which this charge can influence other charges. We are taking here a point charge, that is a very small charge at certain distance named Q naught. This is the Q naught is the test charge. It is called test charge. Usually we take its nature as positive and the magnitude very small. The reason behind taking this test charge as positive we'll discuss later on, and very small. The reason behind very small, so that this charge can be influenced by other charges easily with the great magnitude. Okay, if we'll take a very large amount of charge, that is the heavy charge, might be it will not influence, but it will start influencing other charges. So we have to find actually the nature and the field. Actually, not nature, you can find the nature also, the field of this charge. That's why we are taking here the charge as negative. Now, student, here a positive charge, and we placed here the test charge, that is the point charge, test charge. You will see if its nature is positive, and this is the positive charge, this charge will start repelling. If this would be the negative charge, it is the minus Q, then what will happen? If you will place a test charge over here, it will start attracting towards this charge. Easily you can say this is repelling and this is attracting. Easily you can say, student, that this charge is attracted by this one and this charge is repelled by this charge. That's why this charge Q naught is placed somewhere. These two charges can influence. It means this charge is placed in a field which is imaginary, you cannot see. It is the field, and in the field of this charge Q naught is placed. That's why it experiences some force. So students, in similar way you can define the electric field. So electric field is nothing but the space or area under which, up to which this charge can influence any other charge with its effect of static electricity. And this is the concept of electric field actually. Now students, this is the definition, but mathematically you need to define this electric charge in other way so that you can solve numerical questions from here. Okay, now will define mathematically this electric field. So the electric field mathematically, it is defined as, it is a vector quantity. Remember, it is defined as the force, electrostatic force per unit test charge. It is Q naught, force per unit test charge. This is the vector quantity. Now, what is the meaning of this force per unit charge? Actually, student, the meaning of force per unit charge is that we have been placed here in our system. We are having two charges, minus Q, Q naught, here plus Q, Q naught. So this Q naught will experience force and it is F. So electric field is nothing but the force acting between these two charges per unit test charge you have been placed, per unit test charge, and this will give you the strength of electric field of that charge. This electric field also termed as in many ways. It is the electric field strength, electric field intensity. Okay, so this electric field can be defined as the electrostatic force per unit charge. Of course, if you write the unit from this definition, you can write the unit of this force will be Newton and the unit of this charge as a unit will be Coulomb. So Newton per Coulomb will be the SI unit of electric field. Now student, you can find here the simple calculation for this electric field. That is the mathematical formula you can find out over here for electric field. Suppose you can write here the derivation of electric field. Okay, so you can take a positive charge for which you have to find the electric field. This is our point of observation, and here we have placed, sorry, this is our point of observation, and here at O we are having a charge, positive charge. We are finding electric field at point P. This is test charge we have been placed. Okay, Q naught, as we have been discussed, this is a test charge, very small charge, and must be considered as a positive. Of course students, if this is positive charge, then direction of force will be outward. This is the direction of force. Later on we will study how the direction of electric field we have to take, because it is a vector quantity, and vector quantity should have both magnitude as well direction. Suppose the distance is r from the point charge for which we have to find the electric field. So according to definition, student, we can write here the electric field is nothing but the force between these two charges per unit test charge, because we have to find electric field over here at point P. Now the force between these two charges, using Coulomb's law, we can write here the K Q1 Q2 over R square. Okay, and the direction of force, it is r cap along the vector r, it is r cap per unit test charge. So divided by Q naught, it is electric field at point P in vector form. Now student, you can write here the EP, that is electric field, is equals to, thus Q naught will be cancelled out, KQ over R square and the unit vector R, this one. This can be also written as EP, that is in vector form, electric field at point P. It is KQ over R square and vector R over R, that is EP. It is KQ over RQ and vector R. So this is the mathematical formula to find the electric field, which is very simple. Now students, if a charge is placed in electric field, if any charge is placed in electric field, then you can find the force on that charge using this definition. That's what the electric field is, force per unit charge. Okay, so be aware in your mind and try to make this is your as a note point. As we know that electric field, it is force per unit charge. And what was that charge? Q naught. This charge was placed in electric field. In electric field of which charge? Q. This charge is placed in electric field of which charge? Q. That's why this charge is experiencing force. How much? It is F. It is quite obvious. If any charge will placed in presence of electric field, this charge will start experiencing a force. Suppose this is an electric field. Okay, uniform electric field. Uniform electric field. We'll talk about the non-uniform electric field also. Okay, so this is the uniform electric field, and in uniform electric field the strength of electric field is E. Which one is making this electric field? Actually, whatever may be the source of electric field, but we have been placed a test charge over here. What will happen? This test charge will start experiencing a force. If the direction of electric field in this direction of electric field is this way, then positive charge will always move. Remember, it will always move in the direction of field. If it is positive charge, then it will experience a force in this direction only. And later on we'll study that how this direction help the charge. And the second point, negative charge. Okay, this is the direction of electric field and the strength of electric field is here. If any negative charge placed in electric field, this was positive charge. If any negative charge placed in electric field, then it will experience force opposite to the electric field, opposite to the direction of electric field. Kindly get note down. Positive charge, okay, moves in direction of electric field, and negative charge moves, okay, opposite to the direction of electric field. The very simple, if this is electric field and we place a positive charge, this is electric field, we place a positive charge, it will start experiencing this direction. We place a negative charge, it will start experiencing force in this direction. A positive charge moves along the direction of electric field, negative charge moves opposite to the direction of electric field. Okay, student. So overall we got the two very important formula. What is that? Two very important formula. One, it is F is equals to Q times E. E was F by Q, so Q times E. This is the force experienced by any charge. Which charge? Q. If you are confusing, then write down Q. This is the force experiencing by this charge Q in presence of electric field A. This is the very important first formula. And the second formula you got, E due to a charge is KQ by R square, or which unit vector, or E is equals to KQ by RQ if you are writing here the vector. Okay, now Using this formula, we'll try to solve few question over here. The very simple question, student, if I'm giving you a proton is balanced, okay, a proton is balanced. Suppose this is a proton and it is balanced. I leave the proton. What will happen if we will leave a proton? It will move down due to force of gravity. If this proton is placed, it will move down due to gravity. Whatever may be the very small amount of mass, but it will move down due to gravity. Its charge is E and mass is m. Mass is m. So due to its mass, in which direction it will move? It will move downward due to mg. Now the question, a proton is balanced in presence of electric field. This proton is balanced in presence of electric field. Then you have to find the magnitude and direction of that field. Okay, you can take the data. Again, I'm repeating the question. Try to write down, pause your video, and then try to find out the exact answer. If this proton is balanced, this is proton. If this proton is balanced in presence of electric field, then you have to find the direction and magnitude of electric field that balance this proton in the air. Okay, now solution. Of course, students, if this is a proton, it's positively charged, and if it is balanced, it should move down due to gravity, but it is not moving down. It means there's some force acting in upward direction, of course, and this is positive charge. Then it is quite obvious the direction of electric field in upward direction. Are you getting, students? The direction of electric field in upward direction. Direction will be upward of electric field. Now here no more forces are acting, only electrostatic force, and this is the electrostatic force and another force due to gravity. So this force due to gravity will balance by this electrostatic force. So we can write in equilibrium, since it is balanced in equilibrium, we can write the electrostatic force is equals to the mg. The question was to find the strength of magnetic field. Of course, if this charge is q and it is placed in electric field E, then electrostatic force will be how much? It is q times E, and it is equals to mg. So you have to find the strength of magnetic field. It is mg times how much? Q. This is the magnitude. And the direction you got upward. I hope students, then you can solve a similar type of question. If electron is balanced, okay, if alpha particle is balanced in presence of electric field, then what will be the direction of electric field and its magnitude? Okay, student. Now another question, if we discuss, students, as I have been given assignment to the students group or the teachers group, those students are interested to solve the assignment, you can take from your friend. There are number of questions, more than 80 questions for your this chapter electrostatics, that is the 2 chapter of NCERT. This is electrostatic. Okay, student. Okay, so to find the direction of electric field, you know that if this is the positive charge and you wish to find the direction of electric field of this charge at this point, what you have to do? If this is negative charge, to find the direction of field at this point, this is any arbitrary point, you have to find the direction of field due to this charge. It is obvious that this charge will create electric field around this charge, and this charge will also creates electric field around this charge. Then you have to find the direction of electric field as these 2 points. Due to this positive charge, the direction of electric field will be here. How you have to find? Actually, you have to put a test charge. We talk about the test charge. Again, what is the property of test charge, student? The first property, it should be positive, and second property, magnitude should be small. magnitude should be small so that it can experience very extremely small force. Okay, that's why we use the magnitude of this charge as positive. Now what you have to do, you have to place here the test charge. Of course it is positive. What will happen? The direction of force experienced by this charge will give you the direction of electric field. In which direction it will move due to the force? It will move away. Okay, so this will be the direction of electric field. Now you place again the test charge over here. What will be the direction of force? It will be towards. So this will be the direction of electric field. So to find the direction of electric field, it is the very simple method. Put a positive charge, that is the test charge, and the direction of force will give you the direction of electric field. Okay, now you can study the principle of superposition over here also. Okay, that is very simple. You have been studied already in force, so you can apply the same here in electric field, the superposition principle. If you are having the number of charges and you have to find the electric field at any point, then the vector sum of all the field due to the individual charges will give you the net electric field. This is the simple superposition principle. Okay, nothing very much to do in superposition principle over here. Okay, simple question. This is a line at point O. You have to find, this is the observation point. Okay, right, P, observation point, you have to find the electric field. You are having two charges, 1 and 2. This is minus 4 microcoulomb, and this is minus or plus 1 microcoulomb. Distances are 1 meter and 1 meter. You have to find E net at P. Okay, what will be the E net at P? Pause this video and try to solve what will be the electric field. I am giving you the hint here. At point P there will be two field, one due to this positive charge and another due to this negative charge. You can find the direction easily and apply the formula. You will get the answer. Now the solution. At point P, due to this positive charge, the field will be in this direction. Suppose it is E1. And at point P, due to this negative charge, field will be towards. So it is E2. If it is the x-axis, then E net can be written as E2 minus E1 direction I cap. E2 in positive direction, E1 in negative direction, and I cap. Now E net you can find E2. E2 was due to the negative charge. So K, Q, again you have to take only the magnitude, not the nature. Remember student, as in force we have not taken the nature because nature only gives the direction. Already we have taken the direction. Okay, so you don't have to use the nature. Try to use and always use only the magnitude in electric field and electric force. So it is K Q 4 times 10 power minus 6 KQI R square. What is the separation between this point P and minus 4 microcoulomb charge? It is 2 meter. So it will be how much? 4. What should be a unit? Yes, Newton per coulomb. This is the force, field E2. Now E1. E1, it is minus, here minus E1. Again, K Q divided by R square. It is 2 square. Newton per coulomb, direction I, sorry student, K, cap. Now you can solve this question. It is as 2, there is a 4, will be cancel out. K times 10 power minus 6 minus K times 10 to the power minus 6 I cap 0 Newton per coulomb. this is the net electric field at point P. We have been calculated. Okay, try to solve another question. Now you have to solve this question by yourself. This will be your classwork. Okay, so this is the point P. Okay, simple question I'm giving you. Minus 1 microcoulomb, minus 1 microcoulomb at 1 meter, 1 meter. Find out. Another question. Both the negative charges are here. Minus 1 microcoulomb, minus 4 microcoulomb, plus 9 microcoulomb. 1 meter, 1 meter and 1 meter. You have to find the net electric field at point P. These two are your classwork. You have to solve by yourself. Okay, student. Another question of different type. As example, this is observation point. You have to find the net field at point P. This is the positive Q and this is negative Q. Both are situated at a distance r from point P, and this is the x-axis and y-axis. What will be the net field at point P? Easily you can write the direction of electric field due to this negative charge will be towards this one. It is E1, and due to this positive charge will be in which direction? Downward. It is E2. Now E net, you can write here the E1 I cap minus E2 j cap. Here minus sign we are using due to because this electric field in downward direction. Now you can solve here. E1, this is the electric field due to this charge. It is k q divided by r square. Okay, direction I cap minus second k q by r square and the direction j cap. This is the minus. Now k q by r square I minus j. So k q by r square and magnitude of I minus j or I plus j or minus I plus j, whatever I plus j or I minus j, it is root 2 magnitude. Directly you can write. So the electric field will be this one, Newton per Coulomb. You can find the direction also in vector form, students. For direction we haven't studied the tan theta, since this is the electric field. Of course, with the x-axis, if you find out the direction theta of which net electric field, tan theta is coefficient of y by x. We have been studied. If we are finding the direction with x-axis, then x would be as denominator, and the coefficient of y, what is this? Coefficient of y, it is this one, minus kq by r square divided by coefficient of x. What is that? The same but positive, kq by r square. Now it will be cancelled out, and tan theta will be how much? It is minus 1. That is theta equals to minus 45 degree. With which axis? With x axis. So negative 45 degree will be in this direction, and this is the magnitude and direction. In same way you can find out the various question you can solve. Now I hope you have been written, or you can write by stopping the video, pause the video and note down another question. Okay student, I am giving you this question to solve. Try to solve this question as your class work. The same question we have been solved in electrostatic force. This is the observation point. Here minus q is placed. I hope you will be much interested to solve this question. I should not solve this question. And equilateral. The charges are placed at two vertices of equilateral triangle, and the third vertices is the observation point. We have to find out the electric field. Okay, student. So try to solve this question. Now, I'm giving the hint for those students are not able to understand how to solve this question, or those have been left to see the video. It would be better that if you go back and see the rest my lecture. Okay, this is the positive charge. Of course, the direction of electric field will be in this direction, and this is negative charge. The direction of electric field will be towards E2. Okay, now we're having two vector. Of course, this point is r distance away with magnitude q. This point is r distance away with magnitude q. So the electric field will be same. So you can write this as E, and this is also as E. And these two vector are inclined at how much angle? Since it is the 60 degree, it will be how much? 120 degree. So you can find the E very easily. Okay, E will be how much? KQ by R square. This is the magnitude for both the charges, and electric field will be root under E1 square plus E2 square plus 2E1 E2. Since here both the electric field are E, cosine theta, how much it is? 120 degree. Okay, now student, you can find the value by putting this E. Suppose this is E only, and you can find the answer. Since it was hint, but I have been solved up to great extent. The next question, try to solve by yourself. I'll not give hint anymore. Now you have to find the electric field at observation point P. Okay, so this is your question. This is the square. Okay, and the three charges are placed. Okay, four charges are placed at four vertices. And the simple question, minus q, plus q, minus q, and plus q. This is the square of 2 meters each. Okay, r distance. Okay, let me generalize this question. R and R, you have to find at the diagonal bisector O the net field. E net at O is equals to what? You have to give the answer. The next, your classwork. Again, this is the square, minus q, plus q, r distance, square. This is the origin point. You have to again find the net at P. At P. Okay, student. So, student, this was a simple question, and today we are closing this lecture. Thank you, student.